Where space exploration has taken us to the Moon, Mars, and beyond, one of the most exciting endeavors in recent years has been the study of exoplanets, planets that orbit stars outside our solar system. Of these exoplanets, one stands out for its proximity to our own Sun, Proxima b. This Earth-sized planet orbits Proxima Centauri, the closest star to our solar system, making it an incredibly important object of study for astronomers. For years, scientists have speculated about the potential for Proxima b to harbor life, with its location within the habitable zone of its star, suggesting that it might have liquid water on its surface. However, despite its close proximity, detailed images of Proxima b have remained elusive, with only distant blurry observations made through ground-based telescopes. That was until the Webb Space Telescope, the most advanced space observatory ever launched, made a groundbreaking achievement, a quantum breakthrough that revealed the clearest image of Proxima b ever captured. This breakthrough is not just a leap in our understanding of Proxima b, but a monumental milestone in the history of space exploration. The James Webb Space Telescope, or JWST, has been providing humanity with unprecedented views of distant galaxies, star-forming regions, and even exoplanets. But this latest discovery marks a dramatic step forward as it opens a new window into the study of exoplanets in ways we've never imagined. Let's dive into the specifics of this quantum breakthrough, the technology behind the Webb telescope, and what this new image of Proxima b reveals about our potential future in space exploration. What is Proxima b? Before we get into the breakthrough image captured by the JWST, it's important to understand why Proxima b is so significant. Proxima b is an exoplanet located just over 4 light-years away in the constellation Centaurus. It orbits Proxima Centauri, a red dwarf star that is part of a 3-star system known as Alpha Centauri. Proxima Centauri itself is the closest star to our Sun, which makes Proxima be the nearest known exoplanet that could potentially host life. Discovered in 2016 by astronomers using the European Southern Observatory's HRPS spectrograph, Proxima b has since been the subject of intense study. This planet is about 1.17 times the size of Earth, placing it firmly in the category of Earth-like exoplanets. But what really sets it apart is its position within the habitable zone of Proxima Centauri, also known as the Goldilocks zone. This is the region around a star where conditions are just right for liquid water to exist on the planet's surface, a crucial ingredient for life as we know it. Because of its proximity to Earth and its potential to harbor liquid water, Proxima b has become one of the most studied exoplanets in the search for extraterrestrial life. However, due to its distance from Earth and the glare of its host star, studying Proxima b in detail has been a challenge. That is until the arrival of the JWST. The James Webb Space Telescope is a marvel of modern engineering built to peer deeper into the universe than any of its predecessors. Launched on December 25, 2021, the JWST is designed to operate primarily in the infrared spectrum, allowing it to look further into space and capture the light emitted by the oldest and most distant objects in the universe. Unlike the Hubble Space Telescope, which observes primarily in visible and ultraviolet light, JWST is equipped with instruments that can see infrared light, wavelengths that are invisible to the human eye, but incredibly important for studying things like exoplanets, star formation, and the earliest galaxies. The JWST's unprecedented ability to observe distant objects with clarity comes from its large 6.5-meter primary mirror, which is over twice the size of Hubble's mirror. This allows it to gather more light, resulting in clearer, more detailed images of distant celestial objects. Furthermore, the JWST is located at a position known as the Second Lagrange Point, or L2, about 1.5 million kilometers from Earth. This location is ideal for observing the universe without interference from the Earth's atmosphere or light pollution. The instruments on board JWST, such as the Near-Infrared Camera, NIR-CAM, and the Mid-Infrared Instrument, MIRI, allow it to observe exoplanets with unprecedented sensitivity. JWST can analyze the atmospheres of exoplanets, study their composition, and even detect the presence of water, methane, and other gases that are potential indicators of life. This is exactly what it has done with Proxima b. The quantum breakthrough in imaging Proxima b in unprecedented detail has been years in the making. Scientists have long been trying to get a better look at Proxima b. But despite their best efforts, the planet has remained a faint blurry speck in the distance. Traditional ground-based telescopes have had difficulty observing such a distant planet, especially given the brightness of its host star, Proxima Centauri. Observing an exoplanet requires isolating the planet's light from that of its star, a tricky task that requires advanced technology and precise instrumentation. Enter the James Webb Space Telescope. Thanks to its powerful infrared capabilities and advanced techniques like coronagraphy, Where a special mask is used to block out the light from a star, JWST has finally been able to capture an image of Proxima b that is far clearer than anything we've seen before. This quantum breakthrough represents a leap in our ability to study exoplanets. For the first time, scientists have been able to directly observe Proxima b in incredible detail. The image captured by JWST shows the planet with remarkable clarity, revealing key features about its size, composition, and potential habitability. The most important part of this breakthrough is that JWST was able to capture infrared light from Proxima b, which allowed astronomers to get a better sense of its atmosphere and surface conditions. The detailed image reveals faint atmospheric features that were previously hidden from view, as well as information about the planet's potential climate. One of the most exciting aspects of this quantum breakthrough is what the image reveals about Proxima b's atmosphere. Using JWST's infrared capabilities, scientists have been able to detect the presence of certain molecules in the planet's atmosphere. The most promising discovery is the potential presence of water vapor. Water vapor in the atmosphere of Proxima b suggests that the planet may have liquid water on its surface, a key ingredient for life as we know it. In addition to water vapor, the image also revealed traces of other gases such as carbon dioxide and methane. These gases are significant because they can be indicative of biological processes. On Earth, both methane and oxygen are produced by living organisms, so their presence in the atmosphere of Proxima b could be a sign that microbial life might exist on the planet. Of course, this is still speculative, and further study is needed to confirm whether Proxima b could truly harbor life. The discovery of Proxima b's clearest image and the potential signs of life is a huge step forward in the quest to explore exoplanets. However, we are still only scratching the surface of what the JWST and other future space missions will reveal about Proxima b and other exoplanets. In the coming years, astronomers will continue to study Proxima b in greater detail. One of the most exciting developments in the near future is the possibility of sending a probe to Proxima Centauri to study its planets up close. Although this is still many years away, advances in space technology, such as the development of ultra-fast propulsion systems, could make missions to our neighboring star system a reality. Proxima b could become one of the first exoplanets to be explored directly, providing us with invaluable information about what lies beyond our solar system. The quantum breakthrough in imaging Proxima b is a landmark moment in the history of space exploration. Thanks to the Webb Space Telescope, we now have the clearest image ever captured of this Earth-like exoplanet along with crucial data about its atmosphere and potential for harboring life. This discovery is not only a major achievement for astronomers, but a giant leap forward in our understanding of the universe. As we continue to study Proxima b and other exoplanets, we are entering a new era of exploration, one where the search for life beyond Earth is becoming a real possibility. The James Webb Space Telescope is our most powerful tool for uncovering the mysteries of distant worlds. And with each new discovery, we are one step closer to answering the biggest questions of all. What else is out there? Are we alone in the universe? The future of space exploration has never looked more exciting. Stay tuned because the journey is just beginning. We would have enough to create endless dunes of cosmic dust. Yet these aren't just grains of sand scattered in space. Each is a potential harbor for life, a cradle for oceans, mountains, storms, and civilizations. The James Webb Space Telescope has allowed us to peer into the faint atmospheres of these distant worlds, detecting chemical signatures that echo the breath of life or the smoldering silence of barren rock. It's within this realm of possibility that the idea of life elsewhere ceases to be a question of if, and becomes a matter of when and where. Consider this: some exoplanets orbit stars not too different from our Sun, basking in a warm habitable zone where liquid water could flow, clouds could form, and winds might howl across alien continents. Others circle dim red dwarfs, tiny stars that burn cooler and longer than our Sun, offering planets the potential for stability over tens of billions of years. Some planets are tidally locked, with one face eternally staring at their star while the other freezes in perpetual night, worlds of fire and ice. In these strange conditions, could life emerge in narrow twilight zones, clinging to equilibrium along razor-thin belts of survivable climate? The James Webb Telescope is also refining our understanding of biosignatures, those delicate traces of molecules like oxygen, ozone, methane, and carbon dioxide, which on Earth are byproducts of biological activity. A significant moment came when JWST studied the exoplanet K2-18b and found intriguing hints of dimethyl sulfide, a compound that, on Earth, is almost exclusively produced by marine phytoplankton. If this signal is real and not a spectral mirage, it may suggest a planet with not only water but also the chemical whisper of microbial life thriving in some alien ocean. But life may not always shout its presence. It could hide behind veils of dust or beneath icy crusts. It could flourish in chemical niches utterly unlike those on Earth, breathing sulfur instead of oxygen, swimming through methane instead of water, or photosynthesizing beneath the light of a crimson sun. With each new exoplanet spectrum collected, we inch closer to discovering not just Earth 2.0, but Earth's distant cousins, strange yet familiar, each with its own story to tell. There's another angle that has shaken the scientific world: the potential for technosignatures. If biosignatures suggest biology, technosignatures imply intelligence. The idea that Webb could one day detect artificial lights on a planet's night side, or patterns of pollution that nature cannot explain, or even the spectral fingerprints of massive engineered structures, opens the door to a profound realization: we might not be alone, and we might not be first. Already, researchers have begun cataloging the most promising exoplanets for further observation, including those with unusual infrared reflections or unexplained heat patterns. Could some of these be planetary cities glowing in the night? Could distant civilizations have terraformed their worlds in ways we can now perceive only as anomalies? The data remains sparse, but the possibilities are no longer just science fiction. With each discovery, our concept of what a planet is becomes more complex. Super-Earths with crushing gravity, hot Jupiters with atmospheres boiling off into space, ocean worlds without any land, and rogue planets drifting between stars, all of these expand our cosmic vocabulary. And yet, in the vastness of this diversity, Webb reminds us that Earth, too, is an exoplanet to someone else. We are a blue speck, drifting in the habitable zone of an average star, our own biosignature rising into space for billions of years. As we send telescopes deeper into the void, we're not just searching for other worlds. We're looking for reflections of ourselves, echoes of biology, of intelligence, of longing. The Webb telescope,